In a building with 4 wings, a lighting contactor uses a 120-volt coil to control a 3-phase 480/277-volt lighting load for general hallway lights. Each hallway receives only 2 phases. Switches are located in all hallways. The voltage rating for the emergency ballast units, or EBUs, should be 277 volts. This is because the lighting load is 480/277 3-phase, but only 2 phases are supplied to each hallway. A 277-volt EBU ensures that each unit can effectively power the emergency lighting fixtures in its respective hallway, utilizing the 2 available phases. When connecting EBU, it is crucial to tie them to circuits that remain energized during a power outage, enabling the emergency lighting fixtures to function. There are 2 primary circuit options to consider. Firstly, connect to a generator circuit. A generator circuit is specifically designed to provide emergency power to essential equipment, which includes emergency lighting. This ensures that when the normal power supply is interrupted, the generator automatically kicks in and powers the EBU through this dedicated circuit. Secondly, connect to a bypass circuit. A bypass circuit is commonly found in buildings equipped with redundant power feeds. This circuit provides an alternate power source to critical loads, such as emergency lighting, in the event of a failure in the normal power feed. By connecting the EBU to a bypass circuit, you ensure that emergency lighting remains operational, even if the primary power source is unavailable. It is essential to follow all applicable electrical codes and regulations when installing and connecting EBU to ensure safety and compliance. These codes and regulations dictate the proper wiring methods, overcurrent protection, and grounding requirements for emergency lighting systems. Proper installation and adherence to codes are critical to ensure the reliable operation of emergency lighting during power outages and to prevent electrical hazards. The 277-volt rating is crucial because it aligns with the phase-to-neutral voltage in a 480/277-volt system. Connecting to a 480-volt circuit would damage the 277-volt EBU. The generator circuit is usually wired to an automatic transfer switch, or ATS, which detects power loss and switches the load to the generator. The bypass circuit offers a similar function, switching to an alternate utility feed if the primary feed fails. The specific wiring and components used to implement these connections will vary depending on the building's electrical design and local codes. For example, the National Electrical Code, or NEC, provides detailed requirements for emergency systems. Article 700.12 covers wiring of emergency circuits. Article 700.12b specifies independent wiring. Article 700.12b states that wiring for emergency circuits shall be kept entirely independent of all other wiring, equipment, and raceways, unless otherwise permitted in 700.12. B1 through 700.12. B5. This ensures that a fault in the normal power system does not compromise the emergency lighting. Article 700.12. B1 permits emergency circuits to be installed in the same raceway, cable, box, or cabinet as other non-emergency circuits if the emergency circuits are supplied by one or more of the following. Firstly, 2 or more sources of supply, such as a normal source and an alternate source, with automatic transfer from the normal to the alternate source. Secondly, 1 source of supply with emergency backup provided by one or more of the following: storage battery, unit, equipment, or generator set. This redundancy ensures a reliable power supply for emergency lighting. Article 700.12. B2 allows for transfer equipment to be in the same enclosure. Transfer equipment, including automatic transfer switches, is permitted within the same enclosure as other equipment when it is directly connected. Article 700.12. B3 allows fire protection, fire alarm, sprinkler, or standpipe systems to be in the same raceway. Wiring for fire protection, fire alarm, sprinkler, or standpipe systems is permitted to share raceways with emergency circuits. Article 700.12. B4 states that shunt trip devices that operate the normal or recurrent protective device is permitted to be in the same raceway. Wiring for shunt trip devices that operate the normal overcurrent protective device is permitted to be installed in the same raceway as emergency circuits. Article 700.12. B5 permits other equipment if it is used only for the emergency system. Other equipment is permitted to be installed in the same raceway if it is used only for the emergency system. Furthermore, the NEC provides guidelines on the types of wiring methods suitable for emergency circuits. Article 700.9 addresses wiring, emergency system. Article 700.9 covers wiring, general. Article 700.9 states that all wiring from the emergency source to supply emergency loads shall be fully protected by one or more approved means. The means of protection could include, firstly, rigid metal conduit. Secondly, intermediate metal conduit. Thirdly, electrical metallic tubing. Fourthly, listed flexible metal conduit with listed fittings. Fifthly, listed liquid-type flexible metal conduit with listed fittings. Sixthly, mineral insulated metal sheath cable. Seventhly, Type MC cable. Eighthly, other raceways listed for the application. These wiring methods provide physical protection to the emergency circuits, ensuring their integrity during a fire or other emergency situation. Proper overcurrent protection is critical for emergency circuits as outlined in Article 700.27. Article 700.27 states that overcurrent protection shall be provided in accordance with 240.4 and 240.5. Article 240.4 covers protection of conductors. Article 240.4 B covers conductor ampacity. Article 240.4 B states that conductors shall be protected against overcurrent in accordance with their ampacities as specified in 310.15 unless otherwise permitted or required in 240.4. See through 240.4. G. This means that the overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overheating due to excessive current flow. Article 240.5 covers protection of flexible cords and flexible cables. Article 240.5 covers ampacities. Article 240.5 states that flexible cords and flexible cables shall be protected by an overcurrent device in accordance with their ampacities as specified in 400.5 and 400.12. This ensures that flexible cords and cables are protected from overcurrent, preventing potential fire hazards. In addition to the NEC, local electrical codes and regulations may impose further requirements for emergency lighting systems. These local codes may specify additional safety measures such as the use of specific types of emergency lighting fixtures or the implementation of regular testing and maintenance procedures. It is imperative to consult with local electrical authorities to ensure full compliance with all applicable codes and regulations. The selection of appropriate emergency lighting fixtures is also an important consideration. Emergency lighting fixtures should be designed to provide adequate illumination during a power outage, ensuring safe egress from the building. These fixtures should also be energy efficient and have a long lifespan to minimize maintenance requirements. Furthermore, the emergency lighting system should be regularly tested and maintained to ensure its reliable operation. Testing should be conducted in accordance with the manufacturer's recommendations and applicable codes. Maintenance should include the replacement of batteries and lamps as needed, as well as the inspection of wiring and other components for damage or deterioration. By adhering to these best practices, you can ensure that the emergency lighting system is properly installed, maintained, and ready to provide safe and reliable illumination during a power outage. Additionally, it is crucial to document all aspects of the emergency lighting system, including the design, installation, testing, and maintenance procedures. This documentation should be readily available for inspection by electrical authorities and should be updated as needed. Proper documentation helps to ensure that the emergency lighting system is compliant with all applicable codes and regulations and that it is properly maintained over its lifespan. The selection of a qualified electrical contractor is essential for the successful installation and maintenance of an emergency lighting system. A qualified contractor will have the knowledge, experience, and equipment necessary to properly design, install, and maintain the system in accordance with all applicable codes and regulations. Furthermore, a qualified contractor can provide valuable guidance on the selection of appropriate emergency lighting fixtures and the implementation of best practices for testing and maintenance. When selecting an electrical contractor, it is important to verify their qualifications and experience. Check their licenses and certifications to ensure that they are properly trained and qualified to perform the work. Also, ask for references from previous clients to assess their reputation and quality of work. A reputable contractor will be happy to provide references and answer any questions you may have. Finally, it is important to obtain a written contract from the electrical contractor that clearly outlines the scope of work, the project timeline, and the payment terms. The contract should also include provisions for resolving any disputes that may arise during the project. By carefully selecting a qualified electrical contractor and obtaining a written contract, you can help to ensure that the emergency lighting system is properly installed and maintained, and that the project is completed on time and within budget. In summary, selecting the correct voltage rating for emergency ballast units, which is 277 volts in this case, and connecting them to either a generator circuit or a bypass circuit ensures the reliable operation of emergency lighting during power outages. Always adhere to the NEC and local codes, ensure proper wiring methods and overcurrent protection, and engage qualified professionals for installation and maintenance. The goal is to ensure the safety of occupants in the building in the event of a power failure. The electrical system design must consider all these factors to provide a robust and reliable emergency lighting solution. Remember that the emergency lighting system is a critical safety feature of any building, and its proper operation is essential for protecting the lives of occupants during a power outage. Therefore, it is imperative to give careful consideration to all aspects of the system, from design and installation to testing and maintenance. Regular inspections of emergency lighting systems is also important. It is important to conduct periodic inspections of the emergency lighting system to identify any potential problems or deficiencies. These inspections should include a visual examination of the fixtures, wiring, and other components, as well as a functional test to ensure that the system is operating properly. Any problems or deficiencies identified during the inspection should be promptly addressed to ensure the continued reliability of the emergency lighting system. It is also important to keep records of all inspections, tests, and maintenance activities performed on the emergency lighting system. These records can be helpful in identifying trends or patterns that may indicate potential problems, and they can also be used to demonstrate compliance with applicable codes and regulations. Another aspect of emergency lighting systems is the use of battery backup. Many emergency lighting fixtures are equipped with battery backup systems that provide power to the fixtures during a power outage. These battery backup systems are typically designed to provide power for a minimum of 90 minutes, as required by the NEC. It is important to regularly test the battery backup systems to ensure that they are functioning properly. This testing should include a load test to verify that the batteries can provide the required power for the specified duration. The batteries should also be replaced periodically as recommended by the manufacturer to ensure their continued reliability. The location of emergency lighting fixtures is also an important consideration. Emergency lighting fixtures should be located in strategic areas throughout the building to provide adequate illumination for safe egress during a power outage. These areas typically include hallways, stairwells, exits, and other areas where people may need to evacuate the building. The placement of emergency lighting fixtures should be carefully planned to ensure that there are no shadows or dark spots that could impede evacuation efforts. The emergency lighting system should also be designed to provide a consistent level of illumination throughout the building, regardless of the location of the fixtures. In addition to the technical aspects of emergency lighting systems, it is also important to consider the human factors. Emergency lighting systems should be designed to be easy to understand and use, even in stressful situations. The fixtures should be clearly marked and easily accessible, and the controls should be simple and intuitive. It is also important to provide training to building occupants on the proper use of the emergency lighting system. This training should include instructions on how to activate the system, how to evacuate the building safely, and what to do in the event of a power outage. By considering the human factors, you can help to ensure that the emergency lighting system is effective in providing safe egress during a power outage. The integration of emergency lighting with other building systems is also an important consideration. Emergency lighting systems can be integrated with fire alarm systems, security systems, and other building systems to provide a more comprehensive safety solution. For example, the emergency lighting system can be activated automatically when the fire alarm system is triggered, providing illumination for safe evacuation. The emergency lighting system can also be integrated with security systems to provide illumination for security personnel during a power outage. By integrating emergency lighting with other building systems, you can enhance the overall safety and security of the building. Furthermore, emergency lighting systems should be regularly inspected by qualified professionals. These inspections should be conducted at least annually and should include a thorough examination of all aspects of the system. Inspectors should be trained and certified to inspect emergency lighting systems, and they should have a thorough understanding of the applicable codes and regulations. The inspection report should document any problems or deficiencies identified during the inspection and should recommend corrective actions. By having the emergency lighting system regularly inspected by qualified professionals, you can help to ensure that it is operating properly and that it is compliant with all applicable codes and regulations. Proper grounding of emergency lighting systems is critical for safety. The grounding system should be designed and installed in accordance with the NEC and other applicable codes. The grounding system should provide a low impedance path for fault currents to return to the source, which helps to prevent electrical shock hazards. The grounding system should also be regularly inspected and tested to ensure that it is functioning properly. The use of surge protection devices is also recommended for emergency lighting systems. Surge protection devices can help to protect the system from damage caused by voltage surges, which can occur during lightning strikes or other electrical events. Surge protection devices should be installed at the service entrance and at other critical locations throughout the system. The surge protection devices should be selected based on the specific characteristics of the electrical system and the anticipated surge levels. Also, it is important to comply with Americans with Disabilities Act or ADA requirements. Emergency lighting systems should be designed and installed to comply with the ADA. The ADA requires that emergency lighting systems provide adequate illumination for people with disabilities to safely evacuate the building. The ADA also requires that emergency lighting systems be accessible to people with disabilities, such as by providing audible and visual alarms. It is important to consult with an ADA expert to ensure that the emergency lighting system is compliant with all applicable ADA requirements. Additionally, you can use energy-efficient emergency lighting. Emergency lighting systems can be designed to be energy efficient, which can help to reduce operating costs. Energy-efficient emergency lighting fixtures use less energy than traditional fixtures, which can save money on electricity bills. Energy-efficient emergency lighting fixtures also typically have a longer lifespan, which can reduce maintenance costs. There are a variety of energy-efficient emergency lighting fixtures available on the market, such as light-emitting diode, or LED, fixtures and compact fluorescent fixtures. Proper documentation, training, qualified contractors, and ADA compliance are also necessary for emergency lighting.